From the smallest components to the largest assemblies, Autodesk Inventor is the 3D CAD software you need for everyday projects and ambitious challenges. Inventor puts powerful mechanical design, documentation, and product simulation tools at your fingertips to help you innovate with agility, collaborate effectively, and win more business. Inventor provides you with a stable and responsive environment to help you get your projects to production faster. With a complete set of tools for sheet metal, welded frames, tube and pipe, and electromechanical, and direct access to a robust content library and engineering calculators. Shave days off your projects by rapidly configuring products using iLogic design automation technology. Speed up design reviews with a cloud-based tool that protects your intellectual property. Connect directly with AutoCAD for your project workflows. And you can extend the power of Inventor with a subscription to the Product Design and Manufacturing Collection to take your designs further with 2D and 3D workflows, cloud-based design and manufacturing, factory planning, and high-end visualization. Regardless of what you make, industrial machines, conveyor systems, or top fuel dragsters, solve your most interesting problems efficiently and effectively with Autodesk Inventor.
Okay, good afternoon, everyone, and welcome to our part 3 for Autodesk Inventor Essentials training. And before we begin, inviting you to join us, our Inventor User Group. It's Autodesk Inventor User Group Philippines. And to all our brothers and sisters into the world of architecture, engineering, and construction, specifically building information modeling, inviting you to join us in BIM Philippines. So it's facebook.com/groups/BIM Philippines. And of course, we are an advocate of digital creativity. So as usual, inviting you as well to join our parent community for anything digital creativity. So may it be graphics design, video editing, photography, all the way up to creating buildings used in digital format. Inviting you to join us in Digital Creatives Philippines. And lastly, of course, if we're in Facebook professionally, we're also in LinkedIn. So it's Digital Creatives Community. And if you're seeing there, we have also an upcoming training, Robot Structural Analysis Essentials training. Stay tuned for that. And of course, for you to be updated on our upcoming public service with regards to digital creativity. Inviting you as well to join us in YouTube. It's Digital Creatives Worldwide in YouTube. Oh, yes, we're actually live right now as well, streaming to multiple platforms such as YouTube, LinkedIn, Facebook, and Twitch. Okay, so we have a lot of things to do, particularly assembly modeling. If you would like to have an official certificate of course completion coming all the way from Autodesk, we would like you to register. So this is actually free to all who have registered to our fundraising for Solidworks training. So this is actually again free to all who are paid participants of our upcoming Solidworks training. So after this, we'll be proceeding to our Solidworks training. And for you to be part of this, you can also still catch up. If you want to be part of this Inventor training, all you have to do is register. So again, it's solidworkstraining.digitalcreativeslearning.com. And again, lastly, if you would like to receive an official course completion certificate for this Inventor class, please register again in solidworkstraining.digitalcreativeslearning.com. Okay, so we have a lot of things to do with regards to assembly. I want you to fire up that Inventor software. Okay, I'm giving you a few seconds, few minutes. Again, this for you to be able to receive that course completion certificate, you are required to do tasks. Okay, so again, learning is about doing, not listening, not watching. So we want you to create this assembly that I'll be sharing, teaching you. So again, giving you a few minutes, fire up that Autodesk Inventor.
A simple project that would have taken 4 hours, we can now do in 20 minutes. And a complex project that would have taken 2 days, we can do in 2 or 3 hours.
We design, manufacture, deliver, and install custom staircases. Every system is new for that customer, so every system is at least a 1/16 of an inch different. We're often one of the last products that gets installed in a home, and if we don't get it right, we can delay them getting a certificate of occupancy. Without iLogic, it took quite a bit to draw even the simplest of orders.
It was very disheartening how much manual labor went into it.
We could draw maybe one order a day. We turned to the Autodesk Product Design and Manufacturing Collection. Autodesk Inventor and iLogic has allowed us to automate the engineering or project management process.
A lot of things in stair design are repetitive tasks, and iLogic enables us to automate a lot of those so that a human operator doesn't have to get lost in the minutia.
So let's say, we decided to pull a foot off of that floor, we added a wall there. I would come in and modify the environment here, tell it for length, put in either an absolute, or in this case, if they said we'd subtracted 10 inches, I'd do it. And I would just tell it to update all my glass. It's going to automatically engineer it for me. It's going to make it so that it meets all building codes that our product is certified for, and it's going to generate shop drawings and production prints for these as it goes. It's that easy.
We're manufacturing 10 systems, 20 systems a day right now. With the Inventor CAM, we take the exact model that is part of our automation that we've used to design for the customer, and it's already toolpathed. So that production engineer is just posting that right to the machine. It's a huge time savings, and it's a quality assurance. As we build in more and more automation, we continue to drive down potential errors that a user can make.
Welcome to Vero.
Thank you.
Have a seat.
We leverage the Forge Viewer. It enables the customer to view on a web page on their phone exactly what we're engineering and how it will fit into their space.
This looks amazing.
We are now over 10 times the size that we were when we started all of the automation.
Then in the next 5 years, we're going to grow from $100 million a year in revenue to $500 million. Automation is critical for scaling at the rate that we're going. We would not be able to do the things that we are doing today and looking into the future without the Autodesk tools.
Okay, so removing the banners. Going to full screen. And recall on our last session, I instructed you to create this part. So again, this part, this is actually not a part, not assembly. Technically not an assembly. Technically it's a part. A part that has 3 solid bodies, and it all came from a single sketch. So I'm just reminding you, we will continue this activity. And again, today we're going to discover 2 ways on how to create assemblies. So the first one, I would like you to screen capture this drawing. Okay. So the drawing is named as rotator assembly. It's a simple assembly. Again, and it has how many, Brielle? How many?
How many what?
Parts. How many parts does it have?
4.
4. So actually the link L and link R has a copy or duplicate, making it 4. So again, guys, requesting you to screen capture this activity and hoping you have completed the course that we shared about mastering part modeling. Okay, giving you ample time. Let me share this course. This course was given for free to our paid participants. I hope you have created you have taken this course up for you to be familiarized with part modeling. So sharing the link. You may search for this course in education.digitalcreativeslearning.com. Okay, so recall again, we have 4 parts for this assembly. And I want you to notice the plate, cross-link and link L and link R. Notice both of these parts are actually being assembled into the plate. Okay? So which means actually the plate is the sort of our parent part or parent component. This is where actually it's like the trunk, and the branches are all attached or comes from the trunk of the tree. So the plate is our sort of parent component, parent part, and link L and crosslink attaches actually to this plate. So with that in mind, the attack would be initially creating the base part or base component, which is the plate. And this is a simple part, as you can see. Hoping you are already familiar, very quick on how to create parts, simple parts. This is a simple part. Okay, let me just turn on into full screen. So let's begin with the plate. Okay, so within Autodesk Inventor, I'm going to hit Control N. Control N, which means create new file. So next, I'm going to the metric templates. And I want our exercise to be in the units of standard millimeter.ipt. So hovering over here, double left click or simply select that and select create. Double left click. I'm going to hit F6 to be in isometric view. Okay. So next I'm going to hit S for sketch. And I prefer sketching on the XY plane. So again, I am asked, where do we want to sketch on? So select plane to create a sketch or an existing sketch to edit. So selecting XY. And because it's a rectangle, I want you to head over to rectangle, specifically 2-point center rectangle. And as always, the target is having our coordinates in 0 to be at the geometric center. So for the geometric center of this rectangle, definitely this should look like this. Okay. So we haven't applied any constraints yet. That's why I can left click and hold and resize this entity or this rectangle. Next, let's add dimensions. So the shortcut for dimension is letter D. Let's define this, selecting this vertical line, value is 120. This horizontal to be 40. Okay. So again, I want you to follow along. I want you to quickly create this rectangle having a length and width of 120 and
What?
120 and
40?
40. Okay, and next, there's two holes or circles. So instead of creating it here, I prefer creating the circle somewhere around here. Okay. And of course, I can bring this over here, but I prefer doing things on a clean slate. So two circles, hitting D, diameter of these two holes or circles to be 10. Keying in 10, hitting enter. And obviously, these two circles should have the same diameter. And with that in mind, we're going to head up to constraints and simply apply an equal constraint. So selecting equal, I want this circle with the dimension be the same, or this circle to be the same with the circle which has a dimension. So selecting this as well. So notice the equal constraint symbol visible on these two circles. So moving this, I cannot resize this anymore because this is actually equal to what this circle is on the right side. Okay, I want you to follow along. Let's create this one. Very simple. So next, the distance between or the pitch of this two holes is actually 80. And for me, I prefer creating a line from this center point going to this center point. Let me zoom in. So I connected these two circles with a line. And now the horizontal constraint was applied. So if it's not, like for this instance, I have deleted that constraint again. I'm going to head up, selecting horizontal, and selecting this line to be perfectly horizontal. Okay, so next, I'm going to add that dimension. Instead of selecting this line, the dimension is actually indicating that the 80 is the distance of this center point and this center point. Yes, it may be the same, but of course, I am sharing to you or suggesting to you to dimension things in their exact design intent. Because what really is being defined by 80 is these two center points. So keying in 80. Next, notice here on our rectangle, it created construction lines, these two diagonal lines. I'm going to convert this horizontal line as well into a construction line. So with this line selected, left click, I'm going to right click and select construction. Or on our ribbon, you can select center line from the format. Okay, so again, right click, selecting construction. So next, I want this to be perfectly at the center, of course, into our geometric center. And to do that, I'm going to select our coincident constraint up above, coincident constraint. Searching for the midpoint, hovering over here. Notice that green dot, it indicates it's the midpoint. So selecting this midpoint and selecting actually our origin. This red dot is actually, if you go over to our model tree, it's actually this center point. So selecting that center point. So I'm trying to move these entities just to check. And obviously it changed into a dark blue color, which means it's fully defined or fully constrained. Okay. So from that, we're now allowed, I would like to say we're now allowed to do extrusion. So selecting finish, selecting extrude, and selecting this profile. So again, the goal is always to have the XYZ 0, 0, 0 at the middle or center. So for the behavior, I'm going to change this into symmetric. And again, for the thickness, it's 15. And hit OK. Let me select this edge. And if you really want to check, okay, I hit M. I want you to select M. M for measure, selecting this edge. It really is 15, just to confirm. 15. So we're done with this part, but of course, to be organized, let's rename this as Control S. I hit Control S, and I'm going to paste to where I am working on. I mean the project folder, pasting in the location of my project folder. So hitting enter, and again, if you If you have screen captured our activity, this is named as plate. So naming this as plate, hitting enter. So again, showing you our activity this afternoon. Okay, for those who are late comers, you may screen capture this. We're currently done creating the plate. So I have here my 10-year-old. If she can learn this, definitely you can learn this too. Okay, Brielle, what would be our next component to create? What do you prefer? Creating the cross link or the link? What do you want to do? Cross link or link? Just select one. Cross link. Okay, so let's create the cross link. Hiding this. So done with plate, Control N. Under metric, selecting standard millimeter.ipt. I always prefer hitting F6. Okay, and the cross link, I'm going to hit L for me to quickly be into the sketch mode. So again, we're prompted to select the plane to where we should sketch on. So I prefer again the XY plane. I am in the line command. Notice here, a line is being activated. So as an exercise, I want you to left click and I hit left click once more, but I'm still holding my left mouse button. So again, left click and hold, release. So again, left click and hold. So that means I'm still holding my left mouse button. So that means if you hold the left mouse button, you're going to create an arc. So release, left click and hold, connect it to the other, and release. So giving you a few seconds, I want you to be familiarized on holding that left mouse button in order to create a simple slot. Left click and hold, release, left click and hold, release. Okay, so left click and hold to quickly create an arc. Okay, so going back, I have created the cross link. Let's now put dimensions. So I'm going to hit F8 to reveal the constraints that currently exist. And notice here on the lower right, we need a tangent to make this into having this into a smooth transition. So selecting tangent, selecting this arc and this line, resizing this again, hitting D. The radius for this arc to be 10. And it has two circles. Control Shift and C. The shortcut for a circle. Control Shift C. So creating two circles or another one just for demonstration purpose. I'm going to create the circle here. Next, defining the diameter of the circles. So it's 10. And again, selecting the equal constraint to have this circle and this circle equal in diameter. And instead of using the coincident constraint to have these center points aligned with each other, I prefer showing you concentric. So concentric causes two arc circles to have the same center point. So it's actually the same with coincident, but only for arcs and circles and ellipses. So selecting this circle and this arc. So let's define the distance or the dimension there, which has 80D. Selecting these two center points, 80. Okay, and next, of course, I moved our geometry with respect, again, having our XYZ or the center point be at the center. So let's now position this accurately. And instead of creating a diagonal line and then turning it to a construction line, let's utilize our constraints. So I'm going to select our vertical constraint, looking for that midpoint. It's here. Selecting that midpoint and going over to our model tree on the left, selecting center point. So notice it nudged to the left, which means the midpoint and the center point are now aligned vertically. So next, applying the same procedure, but now it's horizontal, selecting this center point and our center point. Moving this dimension. Okay, placing that over here. Okay. So we now have a fully defined sketch. And of course, if this is all in dark blue, we can now hit Finish Sketch or simply select E for Extrude. So prompted to select profiles. It's a single profile. The behavior to be symmetric. Thickness to be 10. And I'm going to select OK. And double click the mouse wheel for zoom extents. So we're done with cross-link, hitting Control S, naming this as cross-link, hitting enter or save. Okay, so yep. Giving you a few seconds to create that cross-link. And showing you again our activity for today. So next, hit Control N. Let's now create the link L and link R. So hit Control N or up to the right. New part. Control N. So again, it's metric standard millimeter.ipt. And I'm going to hit Control S just to quickly save this file. So naming this as simply link. Okay, so again, hitting S for sketch. Let's sketch on the XY plane. Hit L for line. And again, let's recreate or use that attack, that utilizing an arc while in the line command. So left click here, left click and hold, release, left click and hold, going to this endpoint and release. F8. So notice I have two concentric constraints, selecting tangent. What I mean is tangent, selecting tangent, selecting this line and this arc, this line and this arc. Next, this is obviously needs to be horizontal. So selecting horizontal constraint. So let's apply again the same technique. Selecting vertical, searching for the midpoint of this line, aligning it with our center point. selecting horizontal, selecting the center point of that arc and the center point. Let's check. So again, by moving entities, you can find out what needs to be applied. So this one obviously needs to be horizontal. Okay, so next, Control-Shift-C for a circle. Creating a circle from that arc's center point. And diameter for this is 10 as well. So creating two circles, keying in 10, making these two circles equal. Hit D again, defining the radius of this arc to be 10. Hit D again for dimension, selecting the center point and the center point. Distance between them to be 30. All in dark blue. So we can now hit E for extrude. Okay, and for now, I prefer selecting this profile on the left, selecting that arrow, moving it to the right. And as you can see, it's actually 15. But of course, I'm coming all the way from the center and this plate's thickness to be 5. So, if that is 15, there's still an additional plus 2.5, right? Because I'm coming all the way from the center. And we haven't created that plate yet. So 15 plus 2.5. So I'm showing you we can create a mathematical operation inside the dialog box. So hitting enter. And of course, the sketch was consumed by extrusion 1. So all we have to do is twirl this down or expand this. Select that sketch, right click and enable its visibility. Alt V. Okay, so hit E again for extrude. Selecting this profile, pulling this arrow to the left. So directly keying in 12.5. Hit enter. And finally, hit E for extrude again, selecting symmetric. And once more, the thickness for this to be 2.5. But notice we have a whole recess here. So with that, I have selected one profile. I'm holding Control to add that profile. So rotating as well, holding Control, selecting this profile as well. So I have selected 3 profiles. Okay. And of course, turning off the visibility of sketch 1. So right click, turning off its visibility. Control S to save this file. Okay. So again, I'm showing you my project folder. So we have created the link, the plate, cross-link, and link. So these 3 are all complete. So the next thing we're going to create, of course, again, recall all of this 3 has a file name extension of .ipt. And for assembly, the file name extension for that is, I'm going to hit Control N. And as you can see here, the file name extension for an assembly in Inventor is .iam. So let's select standard millimeter .iam. Double left click. Okay, so from here, we now have, it's currently named as assembly 1. If you can see the tab at the bottom. So we're going to bring in, of course, the parent component. Again, that parent component or parent part is actually the plate. So let me show you one of the methods in bringing in components or parts into an assembly. So I have here my project folder. Searching for that plate. So here is plate. And at the background is our Inventor software. I'm going to left click and hold and drag and drop. Again, left click and hold. I'm still holding my left mouse button. Drag and drop on this blank canvas or space. Release. So removing my project folder. And as I release, it quickly brought in our plate into this assembly file. So I prefer seeing the edges, just a personal preference. I'm going to tick this, select visual styles, and I prefer seeing shaded with edges. So just a personal preference. I prefer seeing that edge. And doing that method by dragging and dropping, again, it brought in the part which is plate, and it also added, it made the part fully constrained. And I know that because I cannot move this anymore. This is actually fully constrained. And that, an indication of that as well is having this pin. Again, to remove that pin, it's actually simply ungrounding this. Okay? So that first method. So next one is under assemble. Let's bring in the link. So under place, I'm selecting place, pasting into where our project folder is, and I'm going to select link. Double left click on link. So here it is, left click. So left click brought in the first copy. I can also left click again to bring the second copy. Hitting escape. So next one, there are actually two ways of joining or having things or doing the assembly for these parts. So we have joints and constraints. So constraints are actually more useful when it is all about the drawing, and joints when you're simulating dynamic movements of the assembly. So for now, let's discover constraints. So actually joints was later added to Inventor a few years, but initially the way of doing an assembly in Inventor is using constraints. So I'm going to select constraint. So next, I'm going to select dot. Okay, and definitely it should be piercing in, right? To that dot as well, to that side. So let's check, selecting apply. So notice I have the wrong relation. So I can always edit that or simply delete So this will be in a few practices for you to be familiarized. So instead of that dot, notice I'm going to select this type of selection. It has a red circle and an arrow. So same on this side, hitting F6. We're seeing and selecting the solution. So alternating between solutions. Selecting OK. So moving this. So same again. Let's bring in our crosslink. Heading over to place. Selecting crosslink. Wrapping this here. Selecting constraint. Okay, so selecting the type to be insert. Select. Notice that direction, that red circle on the edge. Left click on that. And same here. Left click on that. Selecting the solution to be aligned. So selecting apply. So definitely this one, same procedure. Left click on that. Notice that selection. So same with this as well. Applying apply. And lastly, selecting this edge and this edge. Selecting OK. So yep, congratulations. That's our first assembly using constraints. And now, of course, hitting Control S, let's name this as rotator-assembly. Hitting Enter. So if I go over to my local folder, it's now here, rotator-assembly.iam. So again, showing you our drawing to challenge you. So again, we want you to follow along. Okay, so hiding this again, showing you our end result using assembly constraints. Okay, so again, giving you a few minutes to catch up. Yep, so once more, inviting you to our communities. In LinkedIn, it's Digital Creatives Community. In Facebook, it's Digital Creatives Philippines. And for anything building information modeling, it's BIM Philippines. And of course, finally, please do join us in Autodesk Inventor User Group Philippines. So welcome, Lucky K. So again, recall the attack we made or the procedure we made for this assembly was, of course, initially creating the parts individually. So here's the plate, the crosslink, the link. So these three, we have created them individually and then created an assembly file and merged them or assembled them all together into this rotator-assembly.iam file. Okay, so next, let's now discover the second way. Now, there are ways. Again, I'm just showing you the two ways, hoping this is enough for you, for us to inspire you to go on and have that initiative to learn it and master it all on your own. So again, here we are back to the part. Again, it's just an IPT having three bodies. So we're going to turn this into an assembly. So again, it all originated from a simple sketch, right? It all originated from a simple sketch. This sketch. Of course, to those who are into architecture, this may be a sort of layout for the doors, the walls, and of course, for product designers or machine designers, this is our layout for this assembly. So the concept is still the same. We initially have the layout and then we extrude things. But of course, for Inventor, it's in a single part, and the single part again actually has three extruded bodies. Okay. So let me turn on the visibility again of these three bodies. Turn off the visibility of that sketch. So next, I'm going to select solid one. I'm going to right click and make components. Again, I head over to solid one, right click, hovering over solid one, right click, selecting make components. So I'm going to leave the defaults. It's slider.am for the target assembly name, the template to be standard.iam, the location still on my preferred project folder, selecting next, and selecting OK. So leaving the defaults. So notice at the bottom, we have another file was created. It's now a slider.am assembly. So hitting F6 for isometric view. And again, I prefer going to the right side. I prefer shaded with edges. Again, shaded with edges. So it's the same. This block is placed and is now grounded. And of course, it cannot be moved. So next, we'll be bringing again the next component. So heading back to plate, what I mean is to slider.assembly. Let me now just close this to have a better view. This was already saved. Control F4, Control F4, Control F4, Control F4. Okay, so a part and an assembly. So I left something out. This part should actually have a hole for this shaft to penetrate into, right? So what I'm going to do is under this part, let's go to modify. Again, modify, select move bodies. And that body would be this peg or the shaft. So I would like to move this offset Y at -50. So notice that green, it's a preview. I'm going to select OK. So now we have an interference, an overlap. Okay, and definitely if we do an assembly, definitely because there's no hole here, definitely this shaft would not go in. So what we're going to do next is I'm going to head up again to modify, select combine. And for the base body, I'm going to select this part. For the tool body, I'm going to select this shaft. And I would like to have a Boolean cut operation. So selecting cut. And of course, I want to retain this body as well. So I'm going to tick or enable keep tool bodies. So selecting OK. The tool bodies visibility was turned off. So we now have the whole. We made a Boolean operation, a subtraction. We subtracted solid 3 to remove the material here, creating the hole for this part. So right click on solid 3, enabling its visibility. Okay, Control S. And from here, we can now head back to how we have created the components. So I'm going to select solid 2, right click, make components. The target assembly is of course here at the bottom. It's slider assembly. Selecting next, selecting OK. So notice it brought in as well the solid 2 body. Let's get back to slider assembly. How about renaming solid 3 into shaft? Let's try to rename this. Let me rename this as shaft. Let me rename this as slider. Let's check the effect if it will copy the name. How about this as the base? So shaft, rename to shaft, this body. Right click, make components. Again, target assembly is this assembly that we currently have. Next, selecting OK. And here it go again. So here it is. Selecting this two parts. And I'm going to unground this because this should be moving, right? So moving this here, placing this here. And this time we're going to utilize the joints. So I'm selecting joint. Okay. So next, I prefer the type because my intent is to have this shaft be inserted to this part. So what that is actually a cylindrical joint. So hovering over any of this. Okay, so I prefer selecting this joint. Okay. So left click here. I want that to go over here. So we have an automatic playing enabled for preview. And selecting OK. So this is currently the effect of that cylindrical joint. And of course, definitely for this one, it would be sliding to this direction. So definitely you're right. The next joint should be a slider joint. So selecting joint. Let me select this initially and this initially. So checking. So notice it's the wrong orientation, right? So again, this needs to have a series of practices for you to be familiarized on the equivalence of selecting the joint constraints. So again, let's select this edge. So notice again, that's the wrong way. Okay. So going back, again, showing you how the joint was applied. So under relationships, we can always see the effect. If we head over, whenever we do joints or constraints, it creates a folder. So here for the joint, it created a relationships folder. So notice if I hit edit, we can see what the selection is. So again, I want you to put in the work to be familiarized. Of course, practice is the key. Yep, so again, let's bring in the make component. So I want you to recall this. Ungrounding this, I have a very small real estate screen. But again, whenever you see this pin, this component needs to be ungrounded. So let me just switch over to a different screen. Okay, going back, ungrounded, selecting J for joint, cylindrical, selecting this joint and this joint origin, and hit OK. So, yep, congratulations. Hoping you have followed along. And this now ends our part sketch, part and assembly essentials training for Autodesk Inventor. So the next step would be encouraging everyone, for those who have registered, or will be sending an email. It's actually education.digitalcreativeslearning.com. We want you to submit all the required tasks, like the one that I have showed you earlier, these two methods of creating an assembly. Send it over to our email, and the next step would be we will once again be contacting you for the instructions on how to claim the certificate. So once more, I hope you learned something new, and coming this December would be this November actually would be our training for SolidWorks. So hoping to see you there. Again, so once more, thank you so much for attending this class. And of course, we will be publishing the condensed version of this training. And yeah, see you again. See you once more, and see you soon for our SolidWorks training coming next month, finally. So once again, thank you guys, and see you next time.
These cars are so violent. It's amazing how much damage we can do in 3.5 seconds.
You're going to win or lose by merely inches, thousandths, 10,000ths of a second.
Everything has to be built right. Everybody has to be on their game.
Hopefully you're on the other side of that, and you get the W.
Collada Motorsports is a professional drag racing team. We compete at 24 events across the country.
We use the product design and manufacturing collection from Autodesk. It makes our job so much easier. Not having to use multiple software packages saves us a ton of time. So Inventor is helpful because it's tied in with everything. You do all your modeling, you do your drawings. When you update in the model, it updates the CAM. So these cars go over 330 miles an hour, and they travel 1,000 feet in less than 3.5 seconds. To accomplish something like that is really tough on the parts.
This is not a business where you can make a ton of mistakes.
If we don't do our job down to the smallest detail, that driver's life is in our hands. Everything has to be built right. Everybody has to be on their game.
Welcome to Charlotte's Z-Max Dragway for the 4-Wide Nationals. Got some great
safety is number one, and then second would be performance. We need to make sure our equipment's strong enough and light enough where we can outperform our opponents.
Currently, they're finishing up the track prep. We've got Top Fuel Dragsters up next for you.
At the 4-Wide Nationals, we had the Autodesk on Doug Coletta's Top Fuel Dragster. My expectation is to win every race we go to.
In lane 2, we have Doug Coletta with the Autodesk car.
So Inventor is helpful because races in our league can be decided by 1,000ths of a second. So if we find something on a part to make it a little bit stronger, a little bit lighter, or a little bit better than what everybody else has, that makes us a big part of winning races.
For Coletta, crossing the finish line first, clocking in over 330 miles per hour.
Seeing something get made and then get put on the race car and us going out and running over 300 miles an hour, that's pretty neat to see.